Number of satellite launches per year is increasing. As the commercial space industry and the popularity of CubeSats continues to grow, the area that makes up low Earth orbit is becoming crowded. For this reason, NASA requires most satellites to have an orbital lifetime that is under 25 years. The average operational lifetime of a CubeSat is 2 years, but the satellite can remain in orbit, becoming space junk that could interfere with higher priority satellites. Our team took on the task of creating a mechanism that can be placed on the CubeSat to increase its average cross-sectional area, therefore decreasing its orbital lifetime. We selected our final concept by modeling several of our proposed designs in SOLIDWORKS and placing each of them in a program called STK. Using these designs, this program calculated the area as well as the orbital lifetime of the CubeSats. As we developed our concept, we began using the 3D printers available in the Space Systems Lab. With these printers, we were able to test different iterations of our design, and we were able to understand what worked and what needed revising. Once we reached a final revision, we sent our models to be printed by CRP Technologies using a material called WinForm XT 2.0. After all the materials were delivered or printed, we started assembling our prototype. First, we attached carbon fiber spars to the central hub and attached the mylar to the spars. We constructed a burn circuit using copper posts, nichrome, and fishing line, and attached it to the retaining ring. We ensured that this circuit could actively deploy our sail by performing a cut test. After this test had passed, we attached the central hub to the retaining ring, wound the spars around the central hub, and secured it into place with fishing line. Through several tests, we achieved inconsistent deployment results. We believe several small design changes would increase the reliability of the deployment. However, CRP was unable to provide printing services for the new parts due to their schedule. A CubeSat in a 700-kilometer orbit would typically have an orbit lifetime of 42 years, but the increased area provided by our mechanism would decrease the orbit lifetime to roughly 10 years, achieving our goal of decreasing a CubeSat's orbit lifetime.